Hello everyone, and welcome to this Networking Basics mini lecture series. In this mini lecture, you will learn how to subnet an address into equal size subnets to meet the requirements of a given network. We will make use of the /24 subnetting chart as well. In this example, you will subnet address 174.14.20.0/24 into equal size subnets to meet the requirements of the network topology that is depicted on the following page. Assume that IP addresses need to be assigned to switches and access points in order to enable network administrators to connect to these devices remotely in order to configure or manage them. Step 1 of our example consists in analyzing the network topology. More specifically, we need to count the number of subnets, and for each subnet, we need to count the number of host IP addresses that will be required. Consider the following network topology. Let us begin by counting the number of subnets, or number of network segments that our subnetting requirements must meet. So here's our one subnet. Here's a second subnet, third, fourth, fifth, sixth, seven, and 8. Now for each network segment in this topology, let us count the number of IP addresses that are required. So let's begin with the Ottawa admin. We have 2 printers, 4 desktops, 1 server, 5 IP telephones, 1 switch, and let's not forget 1 router interface, which is the default gateway for all devices connected on this subnet. So let us count. We have 2, 6, 7, 12, 13, 14. So the Ottawa subnet requires 14 addresses. Let's move on to the wireless access point. We've got 5 plus 3, 8. Plus 1, 9 plus the router. I believe we're at, no, let's count again, I forgot. So 5 plus 3 is 8, 9, and 10. So the Ottawa guest requires 10 IP addresses, and let's assume that these include any room for growth, meaning that these would be the maximum and include room for growth. Okay, now let's look at the WAN link from Ottawa to Montreal. Requires 2 IP addresses. Let's look at the WAN link from Ottawa to Toronto. Another 2 IP addresses. And the link from Montreal to Toronto is another, oops, apologies. Let's just return. And again, Montreal to Toronto is WAN link is 2 IP addresses. Now let's count the number of IP addresses required for the Montreal admin. So we have 4 PCs plus 3 laptops is 7, plus the switch 8, 9. 9 is the router interface, so we have 9. 9. Oops, sorry. So we have 9. The requirement for 9 IP addresses in Montreal. Let us look at the Toronto data center. The Toronto data center, we are looking at 2 for the printer, 3 for servers, 5 for for laptops, 2 for the switch, and 1 for the router. So that's 2, 5, 10, 12, 13. So 13 IP addresses. Oh, sorry. Having a bit of issues here. Now the Toronto net operations. So laptop we need 2. And the switch 1 plus, again, let's not forget the IP address that we must assign to our router interface. So 2, 3, 4. So netops is 4. Now that we have counted the number of subnets and number of hosts required in each subnet, let's proceed to the next step. The next step consists in showing or listing the host requirements from the largest to the smallest. Our network requirements sorted from the largest, Ottawa's admin 14, Toronto data center 13, Ottawa guest 10, so on and so forth. And the last 3 are the WAN links, each requiring 2 IP addresses each. When subnetting for equal size subnets, we have a rule. The rule states that we must subnet based on the largest subnet requirement. And in this particular case, we want to create as many subnets as possible. Therefore, given these 2 assumptions, we subnet based on the following requirements, which are: we need 8 subnets, where each subnet must accommodate or have 14 usable host addresses per subnet. Let's proceed to subnetting our address. Using the /24 subnetting chart, we will find the recipe in this chart that meets the requirement, i.e., we must find in this first row the recipe that meets our network requirements. Based on our network requirements, or based on the analysis of our topology, we need to accommodate 14 hosts per subnet, and we need at least 8 subnets where we want to maximize the number of subnets. So let's look at this case right here where 8 subnet meets our number of subnet requirement. 30 hosts also meets the number of hosts per subnet requirements. Let's look to see if we have another recipe that meets the requirements. This one here, we have 14 hosts per subnet, which meets exactly the largest subnet requirement in our topology. And we also have 16 subnets with this recipe, which provides which provides our minimum of 8 subnets. Now we have 2 choices, 1 and 2, or /27 and 28. But based on our requirements being stating that we want to find the recipe that will yield as many subnets as possible. Therefore, the /28 is the recipe that meets all of our 3 requirements. Therefore, let's eliminate all columns that are not required or that do not meet the requirements, and let's begin, or let's proceed to the next slide, which is, or step 6, which is to assign the subnets to each network segment. And we have not been given any specific instructions in regards to which subnet we should assign to which network. So what we'll do is we'll start from the left and move to the right, where from the left we will assign our first subnet, subnet 0, to the first network that we find on the left, and proceed moving from left to right. You see here our addressing table where Ottawa admin has been assigned subnet 0, and completely to the right we have the Toronto netops subnet, which has been assigned subnet number 7. For each subnet, we're showing the subnet address, we're showing the usable IP address range as well as the broadcast address. What is not shown here is that the subnet mask is a /28. The very last column here shows how many IP addresses that will be left unused after having allocated the addresses to the devices. So for example, AutoAdmin has 0 waste. However, if we look at the WAN links, we have exactly 3 of them. In each we only require 2 addresses for a point-to-point link, and in all 3 cases we're wasting exactly 12 addresses in each of the subnets. To eliminate such waste, we adopt the VLSM subnetting approach. To learn about the VLSM subnetting approach, please view my next video entitled IPv4 Subnetting using VLSM subnetting. One last thing to note about this particular example, we started with 16 subnets and we used 8 and are left, having used 8, we are left with 8 available. Thank you for watching this video. The next video addresses VLSM subnetting example using the exact same topology as we have seen in this example.